Hello again, Tommy Gartlin here from Dundalk IT. So what you're looking at here is the Arduino Uno board. It's a development board for developing microcontroller programs. So the microcontroller is a very interesting chip. So this is a chip here. It's a dual inline package chip. You can see it's got pins on either side. And here we have another type of chip, a surface mount chip. But believe it or not, we can actually have maybe the same functionality in both of these chips, but this one's surface mount, so it takes up a lot less space on the PCB. But the reason we like to use dual inline packages is because in education it's very easy to get access to the pins. You can see in the surface mount package the pins are very close together. So this is the Arduino board, but the main component of this Arduino board is the microcontroller chip here. So what is a microcontroller? A microcontroller is effectively a small computer, believe it or not. It's actually got a processor in there to execute programs. It's got some program memory, non-volatile program memory, to store the program. And non-volatile means that it won't lose the contents when we lose power, when we switch off the power. Just like a hard drive keeps its contents. So the program is actually stored inside the chip, and the processor is inside the chip to execute that program. And there's also a small amount of RAM, which is used for storing just temporary data while the program is running. And what distinguishes this chip from a processor, just a processor chip, it's a microcontroller, so it's used to control things and monitor things as well. And that's what the pins on the chip are for. So with these pins, we're able to connect various electronic components, such as LEDs or as an output, or switches as an input, or different types of sensors like a temperature sensor or pressure sensor. And we're also able to control motors. So that's the idea of the pins in the chip. But I mean, as you can imagine, it'd be very difficult to actually, in a lab environment, to connect to these pins. So that's the point of the Arduino board. The Arduino board brings these pins through the PCB to these connectors on the peripheral of the chip. And it's then very easy to connect to the pins by just inserting wires into the actual connectors. So throughout, how do we identify these connectors? We identify them with numbers. So you can see that on this side of the connectors there's numbers, and here we have what's called digital input outputs. We'll talk about that more later, and they're numbered from 0 to 13. So when we would say connect to pin 0, connect to pin 1, well, you basically put a wire into pin 1 or 2 or 3 in the connector here on the board. And also in our programs we'll refer to those pins as well, because our programs will be able to change the voltages on these pins and therefore influence or control electronic devices connected. On the other side over here we also have some pins. These are analog pins, there's 6 of them. And then we also have power and ground here. So GND means ground, it's 0 volts, and we have a 5 volt supply. So some electronic components require power as well as controlling them. So we need a signal to control them, but they also need power. So for example, a servo motor we'll see later on will have 3 wires connected: power, ground, and over here we have a signal wire. This is our little clock. So when people buy PCs, one of the things they're concerned about is the processor speed, and the processor speed is influenced by the clock. And this is a crystal that generates a clock, and this is running at 16 megahertz, 16 million hertz. So what else have we got? Well, the very important thing here is the USB connection. So this USB connection is connected, indirectly to pins 0 and 1, TX and RX here, which is connected to the chip. And that's how we can download the program or upload the program from the PC and the Arduino IDE editor straight into the program memory on the chip. And once it's uploaded, then it will automatically start running. If you wanted to reset it without uploading it again, you could just hit the reset button. Another way to reset it would be just to plug in and plug out the power, or switch on and off the power, just like you would with a PC. That will reset it and start executing from the beginning again. Over here we have a jack for a separate power supply. So at the moment the USB is providing 2 functions. It's actually providing the power to the board, 5 volts and ground, and it's also providing the communication link, 2 wires, to send data, to upload the program to the device, to the chip. But then when the program is running, we can actually have communication back and forth between the program on this chip and the PC, so that we can monitor what's going on, and we can actually influence what's going on. We can interact with the program. So that's very interesting, and we'll see that later on as well. Okay, so they're the essential parts, and we'll talk a little bit more maybe as we go along and we connect various devices, but just a simple introduction to the Uno board. Now microcontrollers, you should do a little bit of research yourselves on microcontrollers and where they're used. They're ubiquitous, which means they're effectively everywhere. A version of them could be in your smartphones. There's many of them in your car. So every time something appears to become smart, it's probably because some sort of a chip, such as a microcontroller, has been added to it to make it seemingly more intelligent, so it can react to its environment. Because a microcontroller can monitor things, can get information from sensors, it can process that information, and then it can control the outputs. A good example might be, for example, in a car, to automatically turn on the wipers. You could have a rain sensor that detects that it's raining. The program then would, make a decision whether to turn on or even influence the speed of the wipers, and then it would control and turn on the wipers at the correct speed, depending on how much rain is actually falling. Or if it's dark, to automatically turn on the lights. And they're even embedded in the car, and people aren't aware of them. For example, controlling the anti-lock braking system, so that when person brakes suddenly, instead of skidding, it actually applies the brakes in such a way that the car comes to a stop in a shorter distance. And the other buzzword we hear about these days is the Internet of Things, and that means that lots of things are being connected to the internet. So, for example, a fridge, or maybe even the car, for example. And how does it connect to the internet? Well, you have to again put some intelligence into these things, into the fridge. So there might be some microcontroller put into the fridge, and that microcontroller can also have Ethernet connections that would allow it then to connect to the internet, or even a Wi-Fi connection to connect to the internet, or maybe your heating system connects to the internet. And we have wearables, where we have lots of microcontrollers embedded in wearables, like say a Garmin watch to monitor your speed as you're running, or monitor your heart rate, etc. So there's a huge number of applications with microcontrollers, and it's growing at an exponential rate almost. So it's a very interesting area to get into, and it's a very interesting area to be working with. So we'll just switch over now to the Arduino IDE. So I've already connected the USB cable here to the device, but I haven't connected it to the PC yet. So I'm going to open up the Arduino IDE, and actually I'm going to show you where I have a program already installed. You get a folder called, well, I've called it here at the moment, Release May 21, and in there, Welcome Serial Communication. So interesting enough, every program is in its own folder. So if you go here and double click on that, it should open up with the Arduino IDE. And if not, we can talk about that at a later date. So this is just a simple program, and I'll do a separate video to go through this program. But what I want to do is establish communication with the board. So if I connect in my USB port, which I will now, my USB to my PC, the first thing you should notice is that we'll just switch back to the camera for a moment. That little noise is the fact that the 3 wires is connected to the servo, so the servo is jumping around a wee bit because it's suddenly got power. But you can see that, well, actually I'm going to disconnect it, because the program that's in there at the moment is to control the servo, so I'm just going to disconnect that, so it's not disturbing us. And you can see over here we have a light indicating power. So this is the power light, so that's a good sign. The green, the board has been powered up. And this is a LED, and this LED is actually connected to pin 13. And if you don't have a LED that you can connect to the board to test your programs with, we can actually turn on and off this LED here in our program. So this one's just a power LED, should be green, and this LED here we can control. It's connected to actually pin 13 on the board. So there's pin 13. It's connected through the PCB, so it's a built-in LED on the board, but we can actually connect an external LED as well to the board. Okay. So I've connected it to you've seen it powered up now, and I've connected in the PC. So let's see what happens at the other end. First thing we have to do is make sure that the board selected is the Arduino Uno. There's lots of different Arduino boards, very interesting boards. By default it probably is the Arduino Uno, but make sure it is the Arduino Uno. You can see it there. And the second very important thing, which people will get confused with, is the port. Make sure you've selected the port that has the Arduino Uno board connected to it. In this case it's COM8, but it could be something different, and if you connected different Arduino boards it might change as well. So just make sure it's COM8. Then we can just, when we have a program written, like I have one here which I will go through in the next video, You can verify the program, make sure that there's no syntax errors. So these are all computer Arduino IDE commands, and you can see there everything went well. We'll come back to that later. And here is where I upload the program. And the program has been uploaded, and basically what it does, it just prints out some messages. So when the program is uploaded to the board, okay, the processor then starts running the program, and it then starts sending information back through the USB cable. Okay, so the program has been uploaded through the USB cable to the memory in the chip. Then the chip will sort of reset effectively, and the processor then will start executing that program. And this program basically consists of just printing some messages. So what it's doing is it's printing some messages to the pin 0 and 1, which are connected to the USB cable. So sending messages back to the PC that we can view and verify that the program is running. And how do we view those messages? Well, the IDE here has a built-in serial monitor tool. So for monitoring messages, and you just go Tools, Serial Monitor. And if everything is going well, then you should see this. Welcome to DKIT Steps TIY Program 2021. And I'll discuss this program in a little bit more detail in the next video. Okay, so thank you for listening, and we'll see you soon. Bye now.